Hello, so we are back, and this time we have a nice laptop to repair. ASUS Vivobook i3 Gen. Now the problem with this one, apart from the fact is that, let's see what the customer is saying. So the customer is saying ASUS Vivobook 15, I'm not able to turn on anymore after a power outage. I would like to have a look and if possible repair. So the customer is saying after the power cut off, the laptop stopped working. Let's find a plug. So we are looking for a power issue. So 19 volts on the power supply. Good. Plug in the charger. And it's taking 170 milliamps. Hoping is the pre-charge current. Otherwise, this is a very bad sign. And we don't have charging sign here. Pressing the power button, nothing happened. Okay, this is bad. I mean, like instantly when we are plugging the charger, the current goes up, and that's not good. That means it's a dead current. It's not. This current is not going into the battery or to some power supply. It's somewhere. It's a short, and 170 milliamps is telling me the EC chip can be shorted. The EC chip power supply is a linear power supply, so it doesn't have like short circuit protection. So in case the EC chip is shorted, it will show you exactly like around 170 milliamp. But let's see, maybe I'm wrong. Hopefully I'm wrong. Okay, all screws are out. Let's open the laptop. And the laptop is open. No RAM memory. We have a IT EC chip there. I mean, what happened with this laptop? Looks like, like things are missing from the board, heatsink, stuff like that. Okay, anyway, let's unplug the battery. Let me plug the charger. Wait, I heard a click. Lol, yeah, you can hear the click. Okay, so it's taking 160 milliamps. You know what I'm gonna do? I'm gonna burn my finger. What do you think about that? Can we do it by the finger? Ah, lol. Lol, that chip is mad hot. Let's go and check. You see, you don't need a thermal camera. No, you don't need it. You can fix laptops in the way I fixed them for like 10 years working on that shop, you remember? Yeah. And exactly, you know what? Yeah, someone work here. Lol, okay. The customer hasn't said anything about someone working here. Okay, just a little bit of alcohol. So check there, you can see the alcohol is getting evaporated instantly. Now, why someone it will work here? Because the chip is getting hot and they will think, wait, this chip is burned because it's getting hot, which is wrong. Yeah, so the chip is not burned, the output is burned. So the output must be on one of these capacitors. Check there, 10 ohms, 11 ohms. And this one 13 ohms. Now, if we are going to the EC chip, and remember I told you how to check the EC chip. We are like capacitors. Capacitor, and this one is fine. Here, you see like a big track, so this is a power rail. Capacitor, and it's good. Huh? Okay, let's check a different capacitor here, yeah? Capacitor, and it's good. Okay, maybe I'm missing something. Capacitor, and it's good. Okay. Definitely I'm missing something. This coil to ground. Good. Oh, wait. Yeah, actually I don't know what coil is. This coil to ground. And it's good. Okay, then I don't understand. Wait a second, now it's not short anymore. Check here. Now it's not short. No short and no short. How this is possible? We checked together and was short here, you remember? Okay, let me plug the charger. So the charger is plugged in. And what do we have here? Here we have nothing. And here we have 1 volt, which definitely is not good. Okay, let's go to the EC chip. So on the EC chip we have 0. Okay, you know what? Let's take a break. Let me grab the power supply just to be sure the EC chip is good, because otherwise we are wasting time. EC chip plus here, and it's taking 220 milliamps, and that's bad. That's proper bad. So we have the thermal camera. We are coming exactly here. It's taking 240 milliamps, 250. And what is getting? Yeah, the AC chip is dead. Check that. So what we are doing on this case? What AC chip is there? Yeah, it was not getting hot. Yeah, but why was not getting hot? Yeah, it is getting hot. You can see it's getting dry quickly when it's less alcohol. It's kind of strange because let me take out the heatsink, because with 250 milliamps, actually 250 is quite low, so should be fine. Yeah. Okay, let's see what AC chip do we have there. A225E. Okay, so the EC chip has to be programmed. Let me see if I have this EC chip. I have A227E, but we need A225. You know what? Before I'm searching on the boards for another EC chip, we have to check the coils, and that's good. But this one has 0 ohms. Yeah, 0 ohm coil. I'm not happy with that. Coming with current, it's taking 2 amps. Let's see. The CPU, most likely. So the heatsink is out. And we have a shorted chipset. Check there. Shorted chipset. So this board is not worth to be repaired. Replace, yeah, but not repaired. Okay, you know what? I think our best choice is to gamble, yeah? Russian roulette. So we have a board, exactly the same model like this laptop. I mean, about the same model. And they are saying this board is classed as grade F for parts. That means the motherboard is dead and can have shorted CPU and can have components missing. And from the picture, yeah, check here the picture, I can see the battery socket is missing. You can see the battery socket is not here. So that one, it is missing. Tracks are missing. So it is possible, if we are buying this board, actually the only problem to be the tracks which are missing from the charging connector. So this is a tricky battery connector, sorry. The battery connector, and not many knows, you have to pull up the metal, to pull back the metal in order to take out the connector, and not many knows. So what the people, it will do, it will just force the connector up, and it will it will desolder the battery connector from the board. So I think, yeah, for the money this board cost, yeah, because this is like what, like 13 pounds. You know what I mean? I mean, even if I will be to buy the board only for the AC chip, and this is a good deal, you know what I mean, for 13 pounds. So I think we should buy this board and we should try to repair it. What do you think? Huh? I think it's worth. Oh, that's why it's no RAM memory, because the RAM memory is on the other side of the board. Okay, let's buy it. Let's buy it. Let's buy it. Perfect. So we bought the motherboard. Let's wait a few days and see what we can do. So see you in a few days. So we are like 1 day later. Yeah, I ordered the board yesterday and the board arrived. And as we can see, the connector is broken, same as in the picture. But also I can see here some liquid damage. Now, this is not the first time I'm buying from this seller, Cambridge Accessories, I believe it's called. But let me check to be sure. Yeah, I bought faulty motherboards before, and they are like on the description. So if the board, they are saying the board is not tested, that means the board is not tested. And on this case, I'm pretty sure, apart from this liquid damage here and the battery connector, probably the board is working. I mean, clearly the original fault was liquid damage here. And someone, by mistake, broke the battery connector. But let's check to be sure. Now, just checking to be sure, yeah? Remember how much we pay for the board? 1 second, I don't remember how much I paid. Probably like 14 pounds. Actually, 12 pounds. We paid 12 pounds 99p for this board. So here you have some liquid damage. But we can swap components from the other board. Hopefully the coil resistance is fine. We have BIOS. Looking good. The AC chip is looking good. The battery connector. Now on the battery connector we have, this is ground, yeah? And this is plus. And the plus line is here, you can see it? I mean, this is one track. Then we have data lines. And then we have the enable pin here. Yeah, that's quite easy, nothing complicated. Here is looking fine, here is looking fine. Yeah, all is looking fine. Then on the other side of the board, we have the plastic foil, and no one took the plastic foil out. Looking good. The input circuit, yeah, looking fine. Good, let's clean the board here. Let's try with alcohol first. Maybe it's water. Nah, I don't think, nah, it's not water. It's not water. It's not water. It's a sweet liquid. Let me grab some water, yeah? We know the sweet liquids, they are getting clean with plain water. So I have my sparkling water here. Yeah, just a little bit. Yeah, fizzy water. Yeah, that's what I have here next to me. So now we can clean it. Yeah. That's how you clean sweet liquids. And I learned it from my chat, if you remember, years ago. Looking good? Okay, let's dry it. Perfect. Hot air. We have two capacitors which are gone, but that's fine. Good. Let's check the coil resistance. That's more important. So the coil resistance is 13 ohms. That sucks. Or not? No. So the CPU has 2 ohms. The coil resistance 16 ohms. Not sure if 16 ohms it's right or wrong. That's the thing. The main power rail is fine. Huh? Yeah. Main power rail is not shorted. Good. I think we can plug the power and see what's going on here. Hmm? Let me clean a little bit more. Perfect. Good? Perfect. Okay, let's plug a charger and see what it's doing. Lol, we have too much water here. One second, because we are creating more water damage. Yeah, definitely we don't want more water damage. Looking good, right? Good. Let's plug a charger. And we need this pin. No, we need a smaller one. This one. Yeah, that's the one. So switching the power supply to 19 volts. Yeah. And plugging the charger. It's taking 10 milliamps. Check there, 10 milliamps. 10 milliamps does mean my LDO power supply, it's up and running. Where is the power button on this one? The power button. Yeah, I should grab the laptop. It's on the keyboard. We have voltage on the keyboard. Check there, 3.2. Shorting the 3.2, we can't, right? Okay, let's use a tweezer. Shorting the 3.2. And it's doing nothing. Okay, let me check with the laptop. Let me see where is the power button. Okay, you know what? The power button is on the keyboard. Yeah. So, kind of bad, you know, the board is not starting. The 3.3 it is present. The voltage goes to 0. 1 second. What current do we have? We have like 4 amps. We have more than enough. Good. Let's check. And now it's not taking 10 milliamps. We just burned this board. No, the main power rail is not present. One second. The main power rail 0 and it's not 0. Main power rail 24 ohms. Because we have some water, nah, that's fine, that's okay. Main power rail 24 ohms. Okay, the main power rail with 24 ohms is not okay. So what I'm gonna do, I'm gonna lower the voltage, coming with the voltage here, and it's taking 60 milliamps, 70. Yeah, we can spot what is wrong with 70 milliamps. Let's see. I mean, how the board died on my desk? I can't believe. I can't believe. Okay, 70 milliamps. Let's see. Must be some capacitor, right? So with 70 milliamps, check there. What is that? It's a capacitor? One second, let me raise the voltage. And now it's taking 300 milliamps. And what is taking 300 milliamps is... What is taking 3? It's a capacitor, right? Yeah, next to the hole. Yeah, that's the one, right? Yeah, that's the one. Yeah, that's the capacitor. I mean, has no plate, but how this can be shorted? Oh, what the fuck? Lol, I can't believe my tweezer got broken. That's crazy. Perfect, so no capacitor, no shorted capacitor. So if we are coming now again with the power supply, here and here, and it's taking no current, you can see that means it's not short anymore. Let's raise the voltage to 19. Yeah. Let me plug the charger. And the board is taking again 10 milliamps. Yeah, which is fine. So the idea is to short the keyboard pins to ground. And see if the board is coming on. No way, it's not reading the power button. This is ground, right? It's no ground. That's great. This is no... I burned something again. No, 10 milliamps. Okay, let's try one more time. Shorting the pins. And it's not coming on because this power supply is dead. Possible. This one with the liquid damage. It is possible. But the thing is, the AC chip is not even trying to come on. I mean, nothing. Maybe if I lower the voltage, I can see some... No, the current is going down. Okay, that sucks. So the board is not coming on. Okay, this power supply output. This power supply output is 0 volts. Okay, let's grab the old board and see the old board what it's doing. So that's the old board. Let's plug the charger. Plug in the charger and I don't... Yeah, it's taking like 160 milliamps. Okay. Checking that coil, this one, and we have no voltage. Lol, nothing. So this power supply is not supposed to be on. This is confusing. You know what? Let me check if anyone tries something to the BIOS. No, 1 second. What is the resistance of this coil? 1 second. What is the resistance of this coil? 1 second. So the resistance of this coil is 0 ohms. Huh? I mean, this board is completely dead. Check here, 0 ohms on the coil. This is the original board. Yeah, because it was the chipset. I forgot. We checked with the thermal camera. Yeah. So when I came with the voltage, the chipset was getting hot. Do you think on the new board the chipset is dead? Because the liquid damage was exactly here. Okay, that can make sense. But the chipset is not shorted, but kind of shorted. I mean, for me, 33 ohms. No, actually can be good. The resistance depends on the temperature. You can see that 33 ohms. Check that on the 33 ohms. But heating the chipset, you can see the resistance is going down. You can see? Yeah. You know what? Actually, the chipset can be good. Can be good. So what do we have left? We have few resistors, which looks damaged. We have few capacitor, which they are looking damaged. This one is looking damaged. 1 second. I think that capacitor is not connected to ground. Actually, it is connected to ground. Okay, so that's not important then. This it's a low ohm resistor, and it's not good. Yeah, it is good. 1 ohm. Okay. Then what do we have here? We have this capacitor. 1 second. This capacitor, which is good, but it's not good, but has to be good. Okay, I want to replace that capacitor. This one is looking fine. No issue with that one. This one is fine. This resistor is cracked. You can see it cracked. I mean, the quality you see is not that great compared with the optical quality I'm seeing here. But that resistor is cracked. This one has a crack here. You can see it? Okay, so we have to replace this resistor. This one is fine. So the capacitor and this resistor, we have to replace them. And this capacitor, I want to be replaced also. Okay, let's do it. Let's do it. Because because in order for the board to start, need the chipset to be on. Yeah. So we need a little bit of flux here. Good. Little bit of flux here on that capacitor. Good. And a little bit of flux here. Good. Perfect. Okay, the capacitor is out. This capacitor is out. And we have that resistor. And this resistor is out. And clearly the resistor pad is damaged. But that's okay, that's fine. I was expecting this. We have to reapply solder on that pad. Perfect, check that, perfect, yeah? And the pads here are fine. Yeah, great, fantastic. Let's move the components from the other board. Let me remove the board quickly. I mean, it is important from where you are buying faulty boards, because if someone trial ready to repair the boards, there is no point. It's pointless to buy faulty boards. But if you have like good companies, they are selling like untested boards, then you'll have like a chance to actually buy repairable boards. You remember we bought on the past, you remember the Acer board? You remember the MacBook board? Yeah. From the same company. And 1 second, I think was one more, if I remember, the Huawei or something like that. Possible. We have the heatsink from this CPU. Good. Then we have the M2 drive, which is present on the old board. And the board is out. Okay. Now let's start moving the components. Yeah, check that. It's flux. So actually someone worked here. You can see flux? Yeah. Gel flux. That's not my flux. So the capacitor is out. And we are moving the capacitor here. Why we are replacing the capacitor? I don't know. You ask, guys. Yeah, sorry. When the video replacing the capacitor is coming? Check here. Replacing the capacitors. We have this one. Remember I said, our capacitor which we can remove them, and our capacitor which has to be replaced. This one, I don't think this one actually have to be replaced. But the other one, yeah. This one, yeah, has to be replaced. That's not connected to ground. What this is doing, you have a capacitor and a resistor. Probably, it's cutting down some high interference, high frequency interference. Possible. And we have this resistor. And the resistor has to come here. Perfect, so the resistor is soldered in place. Good, everything looks fine. Let's see now, any change? Where is my tool? Perfect. Let's plug the charger and check again. So plug in the charger. Check that, the board is on. 370 milliamps and the CPU is getting hot. What do you think about that? And you'll say, sorry, don't get that happy. You have the battery connector. Yeah, I know. I know. I know. Okay, let me use some fresh thermal paste. Thermal paste. Yeah, but it's impressive, you know, having in mind what's liquid damage on the chipset power supply. Yeah, sunny outside. The chipset is still good. What do you think about that? So the heatsink has to be like that. Yeah. Okay. £12 motherboard, huh? I mean, you know what? Even if the board is like completely faulty, yeah, you have a good DC chip. You know what I mean? You have a good DC chip. We have a bunch of chips. You have a bunch of MOSFETs. Not even counting how many capacitors are here. The way I want you to see it, it's every capacitor, it's a pizza. And here you have a bunch of pizza. You can open up, you know, a pizza shop. Okay, the heatsink is on place. Let's see if we have picture before we are working to that battery connector. So this is the M2 drive. Good. Perfect. Let's put the board into the laptop and test. Only for testing, yeah? Only for testing, we need a screen cable. And nothing, because the board, it will start itself. Yeah, only the screen cable. Good, let me plug the charger. So, plug in the charger. And the board is coming on, check there, like 400 and something milliamps. 500. Come on, chipset, be alive. We have picture, that's crazy. We have picture, it's working. I can't believe. But why is loading the Windows? Because it's a different board, different BIOS. Should ask for a BitLocker recovery key, right? So basically the BitLocker is off on this M2 drive. That's insane. Can't believe it's working. £12 motherboard. Huh? What do you think about that? You know what? I should put some money on the motherboards I found on eBay. Like cheap ones, only for the easy chip. Yeah, that's all what I'm looking for. Even if the board cannot be repaired, but at least I can use the easy chip. Yeah, we have Windows. Check that, huh? Check that. Why are you saying charging? No, it's not charging. No, it's not charging. We have to fix that battery connector, but it's working. That's what is important. Okay, fantastic. Now let's fix the battery connector. Good. So the first thing we have to do is to take out this connector. How we can take out the connector? With the heat from the back. Yeah, very simple. Very simple. We need a mouse, we need this one, perfect. And now, let me take out the nozzle. With the heat from the other side. Yeah, from here. Probably you can't see it, right? Yeah. Now we can take that connector out. Check here, huh? The connector, it's out. Yeah. Perfect. Good, so that's the old board. Yeah. Now on the new board, I think we have to do some tricks here. I mean, how we can solder this? We still have the pins. Yeah, I have to take out that pins. 1 second, it's not coming like that. It's coming on this side. Yeah, like that. Good, so you know what I will do? Kind of a tricky repair, huh? It looks like. Let me take the metal thingy out if I can. I should be able to take it out somehow. Oh yeah. I know how to take it out. So we have to pass over the plastic thingies. Yeah, like that. Yeah, and now the metal is out. Good. So now we have some space here on the back of the pins. So we need 3 4 plus, and that's fine. That's not a problem. This one you can solder after. This one you can solder after, but this one has to be made now. Yeah. We still have a ground pin here, and that's fine. That's okay. Let's make some space here. Perfect. So what do we have? We have the stability points are actually this pin and those two from the back, yeah? I can use after it's fixed a little bit of super glue because the super glue will be, you know, sucked under. Now let me remove the pins. We need a little bit of rosin here. Good. This one is removed. This one. Okay, that's the ground track. No, actually, both are ground tracks. Yeah. Now 180 degree solder wire. Yeah, just to make everything easy. Perfect. And here, yeah, a lot of solder. Solder is good. Rosin is good. Everything is going according with the plan. Yeah, 180 degrees. So that means we can solder the connector from this side. Good. So right now, this is my only concern. And you know what? I'm not really happy to come with the wire like that. I want to come like that. What do you think? Can we do it? You know what? I don't even need this. I don't need this. Yeah. Let me check with ground. This is the enable pin. This has to be connected to ground. 1 second. No, actually, it's not connected to ground. Maybe the EC chip is connecting this pin to ground. Now I'm 100% sure those are data lines. You can see we have some resistors, and this is the enable pin. I'm pretty sure if I connect this pin from the battery to ground, it will be fine. Yeah, but let's make it original. Yeah. Solder, let me grab a wire. We have a wire. Perfect, check that, huh? What do you think? What do you think about that? All my tweezers are gone, you know what I mean? I really have to buy some tweezers. Good. So everything is fine, right? Yeah, looks like everything is fine. Do you think this wire it will jump out soon as I come with the hot air? Huh? No, because the connector it will push down the wire. Yeah, we are fine. We are fine. Then we have those tracks here. Yeah, perfect. And this one. Yeah, perfect. Okay, let's solder the connector. So what I'm gonna do? I will stick the connector here. And I will come with the hot air at 320 degrees. Yeah, this is quite low. We cannot melt the plastic with 320 degrees. Yeah, we can melt the solder but not the plastic. Fine there, fine here. Perfect. What do you think about that? Perfect. Absolutely beautiful. So now we have this wire, this pin which is ground, so it has to be soldered together like that. Yeah. And now both pins are ground. We have this one which has to be soldered there. But I can't see anything. Okay, now we can see better what we are doing. Rosin. Come on. Okay, maybe we need some solder. Maybe we need some solder. Yeah, just a little bit of solder there. Yeah, like that. And the wire is soldered. Not sure if you can see it. Yeah, perfect. Now we can break the wire. We don't need it anymore. So what do we need next? A few more wires and a little bit of solder on the other pins, like here. Yeah, like here. And 3 pins for plus. And that's fine what we did here. Perfect. And here some solder. Good. Now let's solder this wire first. I can't see, that's crazy. It's just annoying. This wire here, good. And has to be soldered here. Perfect. What do you think about that? Huh? Come on. Let me break the wire. Yeah, perfect. Now the next wire, I will do something else, yeah, because it's not really that much space to solder the wire there. Let me dip the wire into the rosin. And we need to solder the wire there. Perfect, come on. Perfect. And we will come with the wire exactly here. Check that. On that resistor. You can see it? Probably you can. More rosin. And the wire is soldered in place there, huh? Perfect. Good. And now we need a proper wire because that's the plus track. And you know, this battery has to carry some current. Yeah, found it. So we need a wire from here. Yeah, like that. Good. Till here. Yeah. So what do you think about that? Perfect or not? It is perfect or not? Just say it. Just say it. Good. Now what you said? You said this wire it's nah, it's okay, it's fine. Now is the moment for testing. Let's test it, let's see. Charging or not? Yeah, I'll put the metal thingy after we see if it's charging, yeah? Good. So the battery is plugged in. Perfect. The charger is here. Plug in the charger. Huh? Nothing. It's not working anymore. That's crazy. No. It's not charging and it's not working at all. Nothing. I mean, the board was supposed to come on from... Wait, it is working. 400 milliamps, but I'm assuming that's the current which is taken by the board to come on. But that's not the charging current. Yeah, the CPU is getting hot. And that's fine. 1 second. Let me check the battery voltage. .4 amps. Check there. 1.4 amps. And the voltage on the battery 7.6 and is going up. Check that. Check that. Check that. Check that. Check that. Check the battery voltage. 7.7. And the voltage is going up. That's mean it's charging. It's charging fine. All good? Happy? It's quite solid. I mean, let's use some super glue. Yeah, let's do it. Let's do it. Super glue or UV gel. What do you think? Probably super glue. Yeah, super glue. Some super glue here at the bottom, and hopefully it will go under or here on this side. What do you think? This is gel. This is no liquid. That's the thing. It's not even working. I don't even have super glue here. That's crazy. Yeah, now. So check that, yeah? And it's going behind. Yeah, check. You can see it's sucked inside. Yeah, that's fine. That's all what we need. Perfect. Perfect. Yeah, I know what you're thinking. I know. This wire which is moving here. That's what you are thinking? Okay, a little bit of hot glue should solve the problem. I do have UV gel, but to use UV gel, I have to clean the rosin. I don't want to clean the rosin. That's the thing. I don't want it. Yeah, perfect. Yeah, perfect. Good. The metal thingy. 1 second. The metal thingy. Yeah, let's put the metal. So the metal has to come like that. Yeah. Huh? What do you think about that? Yeah, perfect. Perfect. Now let's put the board back quickly and let's do a final test. Okay, all back together. I do have few screws to more to put, but I can hear Diana is calling me for food. The food is ready. We have the charging sign here. We have the power on light. Check it, it's taking like over 2 amps. Check there, so it's charging fine. Let's wait for the laptop to come on. Yeah, every time when you unplug the battery, the BIOS gets reset, so we have to wait a little bit. The fan is spinning. Wait, I forgot the screws from the fan. Okay, that's fine. Let's wait for the windows. And everything fine, charging. I'm plugging the charger and you can see the battery is holding the charge. Obviously shutting down because the battery is very low. A well done job. Yeah, we worked like exactly, check here, exactly 1 hour. You can see here, 1 hour, exactly 1 hour. I think worth. Yeah, so the laptop is off and it's taking 1.5 amps. So it's charging fine. Good? Perfect. I'm gonna stop now. I will say, keep your mind open. And sometimes it's worth buying another board and trying to repair the other board compared with this one. I mean, from what we've seen from the beginning, clearly someone worked on the board, but the customer hasn't said anything. But yeah, it is what it is. We fixed it and I'm happy for that. So I'm gonna stop here. I will say thank you for watching. Like, subscribe if you like the video. Only if you like it, of course. And see you on the next one. Bye. Hey, if you find my content being helpful, don't forget you can support this channel by pressing the join button, and you can get instantly access to our members-only cool collection and Discord private channels for support with your repairs. Also, you can have a look on our United Kingdom eBay, where you can find some cool and unique products, United States eBay store, or our Patreon page. Thank you.